Dear friends, welcome to Rajashekhar classes on Applied Data Science with Python. This is lecture number 372. In this lecture, we will try to understand why we take value of +1 and -1 for support vector planes. In the basic formulation of support vector missions or hard margin SVM, we wrote the equation of the separating hyperplane as W transpose x plus b equal to 0. And for the positive hyperplane, W transpose x plus b equal to +1. And for the negative hyperplane, W transpose x plus b equal to -1. Why +1 and -1? Question is why +1 and -1 on RHS of the hyperplanes pi plus and pi minus. Why did you take +1 and -1? It is a very good question. Here W could be any vector, that one must understand. W could be any vector and need not be a unit vector. W is perpendicular to pi. It could be of any length. What is the whole margin? Our margin is, just say this is the margin. I can say this is the margin, or I can say this is gap. Gap or margin, they are of same thing, isn't it? This is our margin. What is our whole margin? Our whole margin is 2 by norm W. Our whole task is to maximize the margin, isn't it? That is our intention. We have to maximize the margin with some constraints. What are the constraints? Here let me say margin or gap is 2 by norm W, where W is perpendicular to separating hyperplane pi. Of course, it will be perpendicular to pi plus and pi minus 1, and it need not be a unit vector. W is any vector and need not be unit vector. What we have to do here? Our whole task is maximizing the margin with some constraints. Now let's assume W star B star equal to arg max of, what is this, W star comma optimal values of W and B. Optimal value of W is W star, optimal value of B is B star, which is equal to arg max of 2 by norm W with constraints. What are the constraints here? Constraints is all the positive points on the above pi plus, and all the negative points are below the pi minus. That's constraint, isn't it? Here objective function is maximizing the gap, maximizing the margin. Constraint is all positive points are above the margin or above the pi plus, all negative points are below the pi minus. Now we will try to understand this with two different perspectives or two different interpretations. This is my first interpretation. Let's assume our hyperplane, let's assume our positive hyperplane pi plus as W transpose. Let me say this is first perspective. W transpose x plus b equal to k. This is pi plus, instead of 1 I am writing k. My negative pi minus is W transpose x plus b equal to minus k, where k is greater than 0. Why we are taking plus k and minus k? Why not k1 and k2? Because we want both hyperplanes to be equally far away from pi. That is our intention. Both hyperplanes. Why we are taking this one? Both hyperplanes pi plus and pi minus. This is pi plus, let me say this is pi minus. Both hyperplanes must be equally far away. Equally far away. I will repeat. Why we are taking plus k and minus k? Why not k1 and k2? Because we want both hyperplanes to be equally far away from pi. We want positive hyperplane and negative hyperplane are equivalently far away from plane pi, isn't it? Your positive hyperplane, negative hyperplane must be equivalently far away from your separating hyperplane. When I have this, what happens to my margin? My margin is, what is the margin? 2k by norm w. What is k? Here k is a constant. From optimization standpoint, we know that argmax of w comma b, the w comma b which maximizes 2 by norm w is same as argmax 2k by those w comma b which maximizes 2k by norm w. That is 2 by norm w, argmax of 2 by norm w is same as argmax of 2k by norm w. If you imagine, if you want to take, if I say some, let me say, for example, let me take one simple example. Here if I take some, if k equal to 4, let me take k equal to 4. If I imagine if k equal to 4, what happens if k equal to 4? Well, this value will become 2 into 4, 8 by, you will get norm w, isn't it? What does it mean? W and B maximizes, W comma B maximizes 2 by norm W and 8 by norm W, 8 by norm W is same in the optimization point of view. Is same, W comma B which maximizes 2 by norm W and 8 by norm W is same in the optimization point of view. That point is important, isn't it? We are taking one is, we are taking, let me say like this, just see from optimization point of view, whether you take one, whether you take or any k, it really doesn't matter. This point is important. From optimization point of view, whether you take one or k, it really does not matter. If I take, for example, let me take 4 in the place of k, what will you get? If I take 4 in the case of k, what will you get? This will be plus 4, this will be plus 4, this will be minus 4. What is your this one? Argmax of, what will you get here? You will get 8 by norm w, isn't it? W comma b which maximizes, W comma b which maximizes 2 by norm w, 2 by norm w is same as W comma b which maximizes 2 by norm w is same as 8 by norm w. From optimization standpoint, you could have taken any k, it still work. That is the beauty of optimization. This is first perspective. We will try to understand our second interpretation. This is my second interpretation. Let me say that is first interpretation. This is second interpretation. What is my pi plus? What is this? W transpose x plus b equal to k. Let me say this is our our pi plus, isn't it? Now what happens here? What am I doing? Just I am dividing with k. What happens? That will be w by k whole transpose into x plus b by k equal to 1. Remember, w is a vector. Each element of the vector is dividing here by k. Here w is a vector. Each element of vector you are dividing with k, isn't it? Now what happened? W by k whole transpose. Of course, this is b by k. I can assume w by k as some w dash, isn't it? Therefore, w dash whole transpose, b by k, let me assume b dash. What happens? Here w is perpendicular to p, isn't it? Norm w need not be unit, need not be 1. It can be any vector. Still it works. We need whether it is perpendicular or not. Still w dash is perpendicular to p, perpendicular to pi, isn't it? Reason to take plus 1 and minus 1 is to just simplify mathematics. This is simple. This is second interpretation. Our first interpretation is this one. This is second interpretation. Just go through this. This is simple and straightforward lecture. If you have any difficulty, please keep a comment. Thank you very much.